In example 5, we're asked to evaluate a given expression for x equals 0. We've done that before, and what this means is that we would take this expression, we would plug in 0 everywhere that an x occurs, and then use order of operations to simplify that expression down to a single number. In this case, we would end up with 0 minus 8 or negative 8. Now what we want to introduce is the concept of function notation, which really just does that exact same thing, but in a more concise way. In example 6, we're asked to use the function below to determine the following result. We are given a function, f of x equals negative 7x minus 8. That's the same expression that we had in example 5. But now what we're told is to find f of 0, is how we would read that. So in order to find f of 0, what we do is substitute 0 into that function everywhere an x occurs. Which leaves us with negative 8. Again, that's exactly what we did in example 5, but it's allowing us to write that information in a more concise way. Instead of having to say evaluate this expression when x equals 0, we can just say find f of 0. And this function notation, this idea of function notation, can be especially helpful when we have multiple different functions that we're considering at one time, which, especially as we get into business applications, if you have a revenue function, a cost function, a profit function, there's just a lot of language we might have to go through to identify what we need to evaluate where. But in example 7, we can see that we're given two functions, g of x and m of x. And then in parts A, B, and C, we can very briefly write out and indicate what it is we need to evaluate. In part A, we want to find g of negative 4. We need to make sure we're paying attention to that function name. So this means we're going to use the function g, and everywhere an x occurs, we're going to plug in negative 4. So that means we'll take negative 4 squared plus 5, which will be 16 plus 5 is equal to 21. Now in part B, again in a very concise way, we're saying instead of using function g, use function m, look at that other expression, and evaluate it when x is equal to negative 2. So we'll evaluate negative 2 times this quantity negative 2 squared minus negative 2, which will give us negative 2 times 4 plus 2, which will give us negative 8 plus 2, or negative 6. And then in part C, we're back to calling on function g, that first function, and we want to evaluate g of 0. So now we know to look back at that first expression and substitute in 0 for x everywhere it occurs, which gives us 5. So function notation allows us to very quickly ask this question about evaluating an expression for a given variable, or for a given value, and allows us to quickly call on different functions using the name that we assign to that function. The letter that we put in front of the function, whether it's g of x, m of x, is more or less meaningless unless it has some specific value, like cost functions are often c of x. But it's, for the most part, irrelevant, except that it gives us a name that we can attach to it to call on that particular function.